Welcome to Believers IAS Academy. So today we are discussing a very important topic, that is earthquake. Why? Because you already aware that in Venezuela there was a earthquake, okay, which has caused very devastating effect to the Venezuela. Okay, in this regard will understand from the UPSC perspective how these earthquakes are formed and why this earthquake basically occurs. Okay, the first and foremost is, as you can see here, the earth is in the motion. Here when I say earth is in motion, what do you mean by motion? Motion basically means it means something is moving, right? So something is moving, okay, which is in constant movement. This is what we call it as motion, right? This is what we call it as motion. It is the most powerful force of what? Of the nature. It is the most powerful force of the nature. Okay, so now we'll understand what is earthquake and what are the causes of earthquake. So here basically what is earthquake? Two important words you have to remember when it comes to earthquake. When earthquake basically means it's what? Sudden release. Sudden release of what? Sudden release of energy. Sudden release of energy from where? From the beneath the earth surface. This is what we call as earthquake. Okay. Now we'll see the definition. As you can see, it's a violent, abrupt shaking of earthquake caused by what? Sudden release of what? Accumulated stress that will release energy. Okay, along the fault line. This is something fault. Yeah, fault line. This energy radiates outward as seismic wave. The waves, the energy which is released is what we call as seismic waves. We don't call it as energy, basically we call it as seismic wave in geographical terms. Okay, sometimes felt thousands of kilometers away. Even this energy or the seismic wave which is released, it can be felt not only in those places where it is affected, but also thousands of kilometers away. You can basically feel this energy being felt. Okay, now first one is, we have understood what is earthquake. Okay, now we'll understand why does this earthquake occur basically. Why this earthquake occurs. Okay, now first and foremost is, we all know, we have studied this tectonic movement, right? Tectonic movement of what? Plates. Tectonic plate movement or movement of plate. Next is volcanic activities. Volcanic activities. Next one is what? Underground busting of caves. Next is human activities. So you have to remember 90 to 95% of the earthquake are caused by tectonic plate movement only. Okay, because since it is a continuous movement of plates. Okay, now we'll understand what is plate also, don't worry. So tectonic plate movement, 90 to 95% of the earth's earthquake is due to tectonic plate movement, even when there is a violent volcanic burst or volcano erupts abruptly, or a strong volcano. So there also a kind of earthquake is formed, and when there is underground burst of caves. If there is any burst underground the caves, this is also will cause activity, earthquake. And even human activities. Human activity in a sense, construction of dam, drilling, this will also cause earthquakes. Okay, these three can be categorized as natural causes, and this one is considered, last one is, as you can see, it is a human made earthquakes. Okay, now we'll study why does this earthquake, how does it formed. Okay, now as you can see, plates are moving, you are aware, plate boundary, which means the lithospheric plates of the earth is basically what? Moving on the asthenosphere, right? Asthenosphere, they are moving in the asthenosphere slowly. Though it is, you can't feel it, but beneath our earth, the plates are actually moving, right? So moving. So this movement will cause various plate boundaries. Okay, the first one is divergent plate boundary. So in this divergent plate boundary, what will happen? The underneath magma try to break down this plate, leading to the movement of this plate. Okay, see, even whenever there is force under the water, I mean, if you say there is a force underground the water, the surface, whatever surface is there, it will diverge. So this is what happening in magma. So magma, what happens? It will forcefully come upside, leading to the breaking of this lithosphere. This will lead to plate movement. One plate will move this side, one plate will move the other side. Okay, this is first one. Second one is transform plate boundary. Okay, in this transform plate boundary, where these plate boundaries will surpass each other. Okay, if you see here, they'll surpass each other like this. Okay, they'll surpass each other. And last one is basically convergent plate boundary, where the denser plate will submerge and the lighter plate will emerge like this. Okay, they will submerge. Okay, so here what happens is, in divergent plate boundary, there are various landforms are being formed. Okay, the first and foremost landform is mid-oceanic ridge. Okay, mid-oceanic ridge, as you can see in our Atlantic Ocean, you can see mid-oceanic ridges. Okay, this is first one. Second one is Rift Valley, right? Rift Valley is also formed. Okay, these kinds of landform, Rift Valley, basically, if you remember, African Rift Valley is very famous example for it. Yes, and next one is transform boundaries. Okay, transform boundary, as I told you, there is surpass each other. And in convergent plate boundary, this is where your fold mountains are basically formed. If you remember Himalayas, right? Himalayas, fold mountain, Andes mountain in South America, right? These are all examples of fold mountains. Even volcanic mountains which is formed by volcanoes. Here also volcano will form. Volcanoes are formed here, though here volcanoes will be much more less violent compared to this. In convergent plate boundary, volcano will be much more stronger when compared to divergent plate boundaries. Now coming back to our earthquake, earthquake, here also, if you can see here, these two plates are basically one plate is submerging, right? Because it is denser, another plate is getting emerged like this. So here when they surpass, here what happens, if you can see, is when they surpass, there is a stress created. Okay, there is a stress created. As the stress releases, the earthquake will occur in these regions. Even if you see this transform plate boundary, to understand this, basically what you can take this. Okay, let's take an example of this. Now there are two plates. This is one plate, this is another plate, or else we can take this example. Yes, we can take this. There are two plates. One plate is moving this side, one plate is moving the other side. So what you can do, whenever these plates are moving very slowly. When they move very slowly, what happens is there is a stress created. When this stress is getting released, what happens? This is where the earthquake is formed. Okay, this is what we call as fault lines. So this is where the earthquake is formed. Okay, so now when the earthquake is formed, the point where the earthquake is formed is what we call as focus. Right? The place where the earthquake is formed, this is what we call as focus. And epicenter, it is the center where the earthquake, first time the earthquake is recorded. This is center, actually the parallel. Okay, here the earthquake has occurred. Above that is on the surface, we call it as epicenter. Okay, I hope you have understood this, epicenter and focus. This is the important point. Now when it comes to Venezuela, basically what Venezuela, as you can see, there are two plates. One plate is Caribbean plate and another one plate is South American plate. So South American plate, as you can see, is moving towards west, and the Caribbean plate is moving towards right. So if you take this example, if you take this example, Caribbean plate is moving towards east and it is moving towards west. So if you see, these plates are moving towards this direction. While they're moving, there is a friction which is happening, or the stress being released. So this has led to this is, if you can see, this is the epicenter. Epicenter. Below this is what we have focus. This is around 30 kilometers. Sorry. Yeah, around 50 to 60 kilometers from the capital, Caracas, which is the capital of Venezuela. Okay, Caracas, it's the capital of Venezuela. It is where the earthquake has occurred. Okay, this is a main important point. Why this is earthquake has happened? This is a kind of transform plate boundary. Okay, now why it was much effective? I mean, it was more effective basically because there were back-to-back two earthquakes. Okay, in the span of only 1 minute. Within the span of 1 minute, there were two earthquakes. The first earthquake was of the magnitude of 7.2 magnitude, which is considered to be a very dangerous sign. Second one was within a minute there was another earthquake which was of 7.5 magnitude. And why, another reason why it was more, I mean, devastating, the second point is the first earthquake was around 20 kilometers from the beneath, and another one was around 15 to 18 kilometers beneath the earth's surface. Okay, so that is the reason why it was very near to the earth's surface. The the focus was very much near to the earth's surface. So this is the reason why it was much more, I mean, devastating. Okay, Venezuela occupies a complex tectonic interface between Caribbean and South American plate. As I told you, this is South American plate and this is Caribbean plate. Okay, one of the most seismically active zone. Seismically active, I told you earlier, in the Americas. Caribbean plate is moving towards, I told you, eastward direction, right? And American plate is moving towards against, which means it's moving towards western direction, as I told you earlier. Okay, there are two faults. One is Bocona faults, major active strike slip fault running towards Andes. Here you see Andes. Okay, in this line only you will see Andes itself. Offshore faults. This is in Saint Sebastian fault is what we call. Now, how do we measure these forces? Seismograph is there, right? Seismograph is there. It's an instrument that captures the ground motion in real time. Okay, ground motion recording the altitude and frequency of what? Seismic wave. Okay, this is basically, we'll record it. Okay, and magnitude scale, it's a Richter scale. This is very important. Richter scale we use in order to calculate what is the magnitude, and the moment magnitude scale is released. Okay, it was how much? It represents the whole 32 times more energy was released. Okay, and data, this is triangulation. In triangulation, data from multiple stations allow scientists to pinpoint the epicenter. This is we used for epicenter and focus. This is what? Epicenter. If you see this is the epicenter on the Earth's surface. This is the focus. Okay. This was the focus. And next we'll see what are the physics of destruction. All seismic waves are not equal. You have to remember, seismic wave also are classified into various types. First one is P wave, which is also called as primary wave. Secondary wave, this is S wave, is what we call as secondary wave, and surface wave. Okay, among these three waves, the fastest wave is P wave, and the slowest wave is surface wave. Now, since it is faster, it will go off very quickly. Okay, it travel through solid, liquid, and arrives first. This is the first one to arrive on the surface. This is secondary, slowest, shakes side to side and moves, and more destructive compared to P waves. And S wave, surface wave, though it is the slowest, it causes the most damaging. It is considered to be a most damaging along the surface, destroying reinforced structures. Okay, it is considered to be the most devastating surface wave. Okay, so next one is cascading impacts. What are the cascading impacts? Cascading impacts basically means earthquake damages rarely stop at the initial stage. As you can see, Venezuela also had the first 7.2 magnitude. It didn't stop there. It was another wave which was of much more energy, which was of 7.5 magnitude, right? So coastal quakes can be displace the sea surface, generating devastating tsunami. This can also cause a tsunami, because when energy is released, beneath the ocean surface, automatically the water which is there, it will cause devastating effect. If you remember, Japan's earthquake has caused tsunami in India also, especially in Goa, if you remember. Okay, this is also one of the things. Saturated and loose soils slopes become unstable and causing deadly landslide also created. Okay, tsunami also created landslide. Okay, ruptures the utility of instigate and fire emergency, long time displacement stay, healthcare issues. Okay, healthcare, because since earthquake happens, there is a low maintenance of hygienes, because some of the sewage water will come off. Okay, this will cause health housing. Many people will be displaced and long-term displacement of social system. Okay, this is what it causes. Okay, cascading effect. Now building resilience. Now, see, we can't stop nature, from this. We can't stop nature. Basically, what happens is you can't control the forces of the nature. But what you can do as a humans, what we can do is we can prepare for it. Okay, so how do we prepare? Engineering solutions, base isolation using rubber bearings, reinforced concrete frames, and flexible joints, allowing building to absorb and display seismic energy. Okay, so basically what the structure of the building, what we will construct, it has to be seismic wear friendly. This can be adopted where there is frequent earthquakes, okay, or where there are active plate movements. In those regions, we can use this technology and seismic mapping, identify seismic gaps and high risk zones, enabling targeted building codes and land use planning to reduce exposure. This is the second thing. And community readiness, which means making people ready by doing what? Mock drills. Okay, mock drills, even not only for earthquake, even for tsunamis, okay, firefighting. So everything also we can do through evacuation drill, building and public education saves lives and prepare for most. Preparation is our most powerful tools. Okay, this thing. And call for action is earthquake. As I told you, earthquakes are basically inevitable, but disasters are not. Stay informed. No, you should know where are the risk zones. Okay, risk and emergency protocols. Okay, build strong advocate and enforce serious resistance constructions, right? And preparing people to ready to face any of this unnatural situations, basically it says. Okay, so this, I hope you have understood why there was a devastating effect in Venezuela, why it was much more devastating, and we have studied about what is volcano, what are the different kinds of volcano, why does the earthquake occurs, right? Basically what earthquake occurs, various types of earthquakes, right? So I hope you have understood what is plate boundaries and all. Okay, through this topic we are able to understand what had actually happened in Venezuela. Okay, through this we'll conclude this topic. Okay, thank you so much.